Doing example 5 from section 7.4, we're asked to find the area between the x-axis and this function, between x equals 0 and x equals 6. So if we follow those guidelines for how to find area under curves between the curve and the x-axis, we want to first graph the thing and just kind of see what it looks like, and then divide up the intervals based on what the graph looks like. So this is a parabola opening up. Its y-intercept will be down here at -9, and then if you check the x-intercepts, if you set this thing to 0, x squared minus 9 equals 0, you get x squared equals 9, so x equals plus or minus 3. It's going to intercept the x-axis at 3. We have to go all the way out here to 6 though. So 3, 4, 5, 6. And if we graph this, we'll see it's going to pass through the axis here. It's going to kind of keep going up here. I don't really have the room to draw it, but what's going to happen is part of the function is going to be here above the axis, and then the other part is below the axis. You can graph this on your calculator or Desmos if you want a better picture of it. But the point is that we do have to split this up, so the total area under the curve, or the total area between the curve and the x-axis, will be this negative area here. So since we know that area is going to be negative, if we want it to be positive as an actual area, we just have to put a negative sign in front of it. So we'll take the negative of the integral from 0 to 3 of the function x squared minus 9, and then we're going to take from that, we're going to add to that the integral from 3 to 6. That's this part right here, and that's already positive, so we don't have to put a negative sign in front of that. And then that's going to be x squared minus 9. So if we add these two things together, that will be the total shaded area here and here added together. Okay, so for the first part we get negative. That one's going to be 1/3 x cubed minus 9x. We're subtracting the whole thing there, evaluated from 0 to 3. And then for the second part, same antiderivative, we'll get 1/3 x cubed minus 9x. This one is now evaluated from 3 to 6. So for this first part, we'll get negative. If I plug in 3 there, I'm going to have 1/3 3 to the third power. Plug in 3 there, minus 9. Actually, it'll be plus 9 times 3. Why will it be plus again? Because that minus is there. It gets distributed. Okay, and then plus the rest of this is going to be 1/3 times 6 cubed minus 9 times 6. And then we have to subtract off what we get when we plug in 3, so we'll put that in parentheses as well. If I plug in 3 there, I get 1/3 times 3 cubed minus 9 times 3. So simplifying all this, 3 to the third power is 27 over 3 is 9, so we get minus 9 plus 27. 6 to the third power times 1/3 is 72, so that's going to be 72 there. 9 times 6, 54, so minus 54 there. Again, 3 to the third power here. You get 27 over 3 is 9, so that's going to be minus 9. The minus distributes here, so we'll have plus 27. So if you put all this together, you should get 54 for your total area between the curve and the x-axis.